this computer. All right, awesome. Well, I'm just going to do the introduction one more time since I forgot to record for those of you who aren't here. Welcome to the Creating Equitable Experiences from the CS Institute. We're super excited that you're joining us, whether you're able to join us for the live call or joining us recording. We're just so excited to have you here over these 3 weeks to explore computer science and see how we can get more computer science to our K-8 students. So without further ado, I think we're going to skip the poll everywhere, but I thought that we could do some introductions of the facilitators. And so I'm going to actually take sharing off now and kind of share what computer science means to us. So Jenny, I'm going to start with you.
Great. I'm Jenny. I'm faculty at UVA. I've had the pleasure of working with a number of you, and I'm really looking forward to working with all of you in this workshop and over this next year. So what does computer science mean to me? I actually, my mom, back in the day, she was actually a computer science teacher in high school. And so it actually makes me have really strong feelings about my mother and her signing me up for BASIC to learn QBasic when I was a middle schooler. And having a lot of access to like 10 print high, like 20 print. So it kind of has this like really strong family sense for me, as well as sort of empowering people to take advantage of technology and being able to design things that specifically solve problems for yourself. So with that, I will turn it over. Eric's next on my screen, so I'll turn it over to Eric.
Hi, thanks. I am Eric Brutter. I have taught CS in high school and middle school, along with CTE and engineering courses, and I'm starting a PhD program with Jenny and Kim, and I'm lucky to work with Luther this year, so I'm pretty pumped to be here. I think CS means I actually have a similar experience on the opposite side. My dad was a hardware guy and an engineer, and he used to bring computers home from work and fix them and bring them back because they didn't have IT staff. So I was a really young kid, and we would take computers apart and he would show me. So on the hardware side, I really got to enjoy computers, and then it's hard to use a computer without programming it. So it was like the next logical step was learning how this thing actually worked. I feel similarly. And I also just love the quick, iterative creativity of computer science. I feel like I get to design and do something really fast, and I enjoy it because it's like just endless learning. So that's kind of my twist on computer science. I'll pass to Nigel.
Thanks, Eric. I'm Nigel. I work for the city schools. My dad was born in the 30s, just after the automobile. And so in the late 80s, he brought a computer home from work because he had no idea what it was or how it worked. And on that computer, it was all DOS, of course. On that computer, there was a little program where you could enter a question and the computer would spit back an answer. And it was magical to my young brain how this computer could answer my questions. And so for me, computer science is about opening the black box, things work and how machines work. I'm going to pass it to Luther.
Hi, I'm Luther. I teach computer science at the University of Virginia, and I recorded entire multi-minute videos about what I think computer science is, which you'll get to see this week. But let me just try to give a very brief version. Computer science is the study of all processes that can be described unambiguously. But that is important because if we can describe them unambiguously, we can make the machine do them instead of us. And so it is the tool we can use to decide what machines do for us. I guess, Kim, we're back to you.
Awesome. Thank you all so much. So I'm Kim Wilkins, and I am currently an EDV student with Jenny and Eric. And I, before that, taught computer science for at least 10, 12 years in K-8, most recently at St. Anne's Belfield School. But before that, I was actually in technology field. I was one of those who kind of went from technology to teaching. So I studied computer science. I worked at IBM for a dozen years. I created websites as a living after that. And to me, computer science is like a superpower. It's just, you just get to use your imagination, solve problems, create solutions, and you don't need to have it's all, there's so many tools out there online that are free. There's so many resources online that can teach you things. You just don't need a lot of expertise to get started with it, except like a drive to want to do it and then a willingness to fail. If you got those two things, it's a superpower that lets you create amazing things. So that's why I love computer science. So I'm also going to model trying to experiment. We had thought about dividing into breakout rooms, but I think there's not a whole lot here that we could probably do some introductions all together. Does that sound okay? Okay, so just a quick who you are, where you're teaching, and what you hope to get out of this experience. So Ryan, I'll start with you.
You didn't give me a chance to write those questions down. No, I'm just kidding. So my name is Ryan Nunley. I teach fifth grade. I have been teaching fifth grade math and science at Walker School. I will be teaching sixth grade math this upcoming year. What was the second question? I'm sorry.
Oh, just what you hope to get out of this experience.
Well, honestly, not to sound too simple, but I hope to just kind of gain skills with programming and maybe even robotics in a way to strengthen the instruction for the students that I teach. So just honestly, just being an overall better teacher.
Awesome, thank you. Christy.
I'm Christy Hartwell. I'm currently teaching kindergarten at Johnson. And a few of you heard my background. I have my undergrad's in IT and statistics, and I have a master's in systems engineering. So one of the things that I would see like on a collegiate level was how many of these undergrads would come in and just like be stuck in their ways and have a really hard time like breaking out of these traditional algorithms that they were given and thinking of what problems were. And I realized that a lot of that is just not being taught as kids are like coming up through the elementary grades. They're just not experiencing problem solving. They're not experiencing flexible thinking, things like that. So I just want to, I guess, get out of the class would be a lot of like, how to really implement this more on like that primary level, and see how we can get more CS in the, into the lower grades.
Awesome, thank you. Mylise.
I'm Mylise. Obviously, I teach at Johnson. I taught kindergarten, and I'm going to teach first grade this year, which I'm super excited about. And I think what I want to get out of the class is really, it feels simple, but just how to implement it more in the classroom and make it more natural. Like I would love it to be these skills to be more a part of our day and not like, this is the 20 minutes that we're going to talk about computer science. So that kind of is my goal of just learning and how to make it applicable to those younger grades.
That's great. Thank you. Matt.
Hi, excuse me. Matt, I teach at Burnley Moran. I really feel like I know nothing about computers. Maybe it's just because of last year. I think this class will give me a chance to connect to students in ways that I haven't been able to. A way to connect with students that know more about computer science than I do, and ways to pull kids in that haven't been turned on to computer science yet.
Great, thank you. Jamie.
Hi, everyone. I am also at Burnley Moran, and I teach K2 gifted resource. And previously, when I was in Albemarle, I did a lot with computer science in the upper elementary. And like you, Christy, I'm really excited to figure out how to make this meaningful for the K2 world. So that's what I'm hoping to get out of the next couple of weeks.
Cool, thanks. Benjamin?
just looking for ways to connect computer science with what we're doing in the classroom every day, and like Christy was saying, think about problem solving. Think about it from a problem solving perspective and using it as a tool for problem solving. I think too often still kids are thinking about the computers and what games can they play, and things like that, and wanting to really be able to teach them how they can use it as a tool in the classroom.
Great, thank you. And Miss Henderson.
So I'm Shanae Henderson. I can't figure out how to change my name, so I'm sorry. So my first name is Shanae. And I teach math at Buford Middle School. This past year, I taught 5 sections of algebra, and algebra and computer science, like, I feel like they should be married. Like they're very, very similar. And so I think I'm hoping to use this class to just kickstart integrating more computer science from the very beginning, like into algebra, because I think it would make algebra so much easier to learn. And I also have a background in computer science. I worked as a software developer, tester, really whole life cycle of computer science. And the biggest thing that I saw is computer science is really a man's world. So my biggest passion is to encourage more girls, more students of color to join the table, because we really need it. We really need diversity in computer science. So if we could start them young, knowing that they're needed at the table, I think our future will be great. So I'm hoping to figure out strategies to learn that as well.
Shanae, I'm so glad you said that, because that is a huge purpose of this workshop. I'm also totally forgot I'm the founder of Tech Girls and the founding member of Charlotte's Women in Tech. So I'm passionate about the gender and racial inequalities and fixing those as well. Well, thank you all so much. Let me get back to.
Yeah, I want to say that too. We definitely have an amazing group of teachers. I think half of you guys have taught my students or taught my own personal kids. And so I'm super excited to be part of this group.
Yeah, and I think it's awesome that you also represent a wide variety of backgrounds and previous knowledge and things like that. And with computer science, that's often what you'll get in the classroom as well. So having, being able to adjust and do things that will help all different ranges is something that you're also going to want to be doing in your classroom. So I think this is awesome. So our goals are that you learn, collaborate. We're hoping that some of you are, in your schools together or whatever, that you'll be able to find ways to collaborate, to do things and to create. You'll be stepping outside your comfort zone. We all will. Anytime you're doing computer science, you're stepping outside your comfort zone because you're going to try something that may have never been tried before. And of course, we want to embrace failure because we're experimenting all the time in computer science. And one of the videos that Luther has that is in your docket to watch is all about CS and experimentation culture. We want you to learn about and get hands-on with CS integration lessons and projects in different subject areas. The goal is that you'll remix or create at least 2 CS integration lessons that you're going to be using in this coming year. And then we hope that we can connect and build a community of practice. Anybody else have anything to say on this one?
No, it's just that when we say CS integration, we'll go into detail with this. We mean like take something you're already teaching, like Shanae was saying, Algebra 1, and be able to infuse computer science into, say, language arts or into math or into a science classroom.
Yep, thank you. So just want to give you like a background of what this is going to look like. Every week you're going to have some learn things to do. So they might be videos, they might be readings, just taking a deeper dive into whatever the theme is for the week. Some do activities, so getting hands-on with CS lessons and concepts. And we hope that you'll be able to, sorry, I completely lost my train of thought because I was just thinking the other do that's especially for the CCS community is to actually come together in person and do some hands-on activities. And so we're hoping that you'll take advantage of that Right now, Wednesday mornings, we've had some people say that that doesn't work for them, so we might try to do some other times as well. Maybe at the end of this call, we can talk a little bit more about that. Obviously, there's these connect times with the Monday kickoff. We have virtual office hours, so I'm not going to go to this link. I'll go to this link and then I'll come back. So we are all available. We want to help you when I want to connect with you. And we've decided last time we just had specific times, and this time we decided to break it up a bit more. And so there's a bunch of times that are available. Anytime you need us, do not feel like you're interrupting us, or that your question isn't worth taking our time. We definitely want to connect with you. Then we have weekly themes. So this week is why should I teach computer science? Next week will be some CS teaching strategies, and the final week will be creating equitable CS experiences. Oh, my PowerPoint skills are not great today. So what's wrong? Why is this an issue? Shanae already identified a big problem, which is the racial and gender gaps in tech. So female students represent 56% of the college student population, but only 21% of CS undergraduates. And in fact, the reason that I started Tech Girls was that when I studied computer science in the late 80s, that number was 37%. So it actually went down. And in 2010, it was 18%. So it's gone up a little bit, but clearly half of the population is not represented in computer science. Boys are 3 times more likely than girls to consider CS-related careers. Black and Latinx students represent 14.5 and 19.4% of the college student population, but just 6 and 8% of the CS undergraduates. And only 26% of elementary schools and 38% of middle schools provide some sort of instruction in computing. And oh yeah, here's the chart that shows what happened to women in computer science. So you can see all the other sort of STEM fields kept going up until they got to about 50%. And then, but for some reason, the computer science did the opposite. And racial diversity has been a real issue in tech companies especially, and it wasn't until pretty recently that they actually started tracking this data and finding that it's not great, and it hasn't, the needle has not moved a lot in this area as well. And sort of the latest thing is in AI, artificial intelligence. So AI is around us more and more, and it's sort of, there was sort of this idea that it was, didn't have biases, it was code, so it couldn't have biases, but in fact, biases got baked into it. And so this is an example of facial recognition and the issues it had with recognizing males versus females and darker versus lighter skin. Luther, I don't know if you know any more about or any other examples in AI. This is the one I picked up for this class.
Sure. I mean, just about every piece of AI is based on taking in data to train the algorithm what it should do. And if the data you bring in is biased, which it almost always is, then those biases get baked in. So job application, things that help you rank jobs often have these biases. There are computer programs that try to pick how much parole or bonds or so on in the criminal justice system have significant biases and so forth. Anywhere computers are used with data as the input, this happens.
And so MozFest, which is Mozilla's annual conference, this last year it was all about AI. Actually, the last 2 years it's been all about AI, because the AI is shaping so much of our future, but there's this power divided between the people creating the code and those on the receiving end of it. So again, computer science education is a great way to help bridge that gap. So what are some characteristics of computing? It's creative. And other facilitators, I'm going to let you join in on this one.
Yeah, I think this is one of the things that is important to understand. CS is fundamentally creative. Once you've done something once, then you use it. So every time you're doing CS, you're making something new every single time. There's no like going through the part you always do. You're always doing something new. And I think that is surprising to some people who aren't used to being creative when they're just using software instead of creating it. But it is core to how it works. I think I added this one to the slides. Maybe I'll talk about this too. When we think about computers, you probably think that the common images that go into the media and so forth are either weird text, the code that people write, or numbers, often just zeros and ones, or maybe people banging keyboards really, really fast. None of those have anything to do with computing, or very little to do with it. What computing is about, CS is about understanding how a series of small steps build up to a larger thing. And particularly in the lower grade levels, you'll see almost all of the standards are relating to this broader idea of just what are processes and how do we organize and express them, with occasional expressing them to computers as one of the things we can do with an express process.
Jenny, I'm gonna throw this to you.
Sure. well, building off of what Luther was saying about being creative, you're building a new solution to some kind of problem, right? So it's about idea creation, about designing that particular generalizable solution, and then enacting that through the specific instructions to give to the computer. And so, yeah. Do you want me to take that too, or Kim, you can?
Oh, sure, I'll take this one. So computer science does not require a computer. So that is one of the unfortunate things about computer science is it often gets conflated with, coding or having to be on a computer, but the concepts behind computer science you can do without a computer. And in fact, the various earliest versions of computer science sort of had this, and we're going to be doing a lot of giving you access to a lot of CS Unplugged activities, which are activities that obviously you don't do without a computer. The great thing about them is they're super hands-on, they're super tactile and creating things in a nice way off the computer. So yeah, it's kind of ironic that it's called computer science.
And that's also true professionally. When I develop software, I spend about as much time in front of a whiteboard as I do in front of a computer.
So I know from a tech girl's perspective, this myth of the hooded dude sitting in his basement coding is a myth that I deal with, especially at the middle school level. That somehow this has become this is what computing is, and you're not collaborating, and it's like super collaborative. The projects that you work on, that are being created out there in the worlds of Google and Apple and all that, they're huge projects that require hundreds of people working together.
It is possible to do it by yourself, but it greatly limits what you can do if you don't have other people helping.
I mean, it's fun to experiment and try things out, but to create something that's really useful and more large scale, you have to collaborate.
So we mentioned that we're going to teach you some integration lessons, and that is not it's not just because we think you don't have space in your curriculum. It's because this is usually what CS is for. It's usually integrated into other fields. In some sense, it's a little bit like mathematics, where once you've learned the basics of math, you then use it in your physics and use it in your economics and so forth. And computing gives you a different set of tools, related in some degree to mathematics, but it is a set of tools that can be used anywhere you want to have a machine assisting you in anything, in coming up with ideas, analyzing data, collecting information, controlling things. CS shows up in all of those. And so I frequently collaborate with people across the entire university in every discipline, because everybody needs to have some computers to help their job go well. This last point, you can do it as a beginner. I have spent many years learning a lot about computer science, but I also can usually get within a week of teaching students in college, they can start doing cool things that nobody's done before they want done. And that is a level that there's a huge space that you can continue to learn, but you can start doing useful things right away. And that is something we're going to hopefully show you as you look at some of the modules and so on we've prepared. Hopefully you'll find some that many of your students will see this in.
So this is, again, a callback to there are some stereotypes, there's some bias, there's some other things that might come up about who can do computer science, but computer science really is for everyone. A lot of the issues I see with especially students self-identifying that they're not good at technology, they can't do computer science, is also related to computer science can be self-taught. And so there's going to be a set of kids in your classes that have gone to camps and, you know, maybe got some computer science other ways, and there's going to be different levels. And so it's really important that just because somebody has more experience at computer science doesn't mean other students can't also achieve and learn computer science. So anybody can do computer science. It's for everybody.
Can I make just a small point? I think as sort of the purpose and for what we're thinking about in terms of integration, being able to provide these types of opportunities for students to try out computer science integrated into K-8 experiences is really a way that we can try to make CS available for everyone. And so thank you so much for being here as K-8 teachers. You know, by the time they get to high school, they've really already self-selected whether they're a computer, they can do CS or not. And so they have to do they self-select into those electives. And so we're really hoping to give every student the opportunity to do CS through your wonderful work and the work with Nigel and Charlottesville City Schools.
All right, so as I was thinking about this, and especially if you're new to computer science, this is going to feel a little bit like the fire hose. We're gonna be throwing a lot of stuff at you. There's these standards, there's these concepts. Sometimes, unfortunately, computer science uses language that's not necessarily accessible, or we use a lot of acronyms. And so I just want to acknowledge that, yes, this is going to be a lot, but our goal is we're going to help you sort of sift through this great amount of detail. This week, we're introducing the standards and concepts and just, computer science in general. Next week, we'll talk about some computer science teaching strategies that you can use to incorporate these standards and concepts. Third week, we're going to talk about strategies that you can use to do equitable CS teaching. And then finally, you have your 2 CS infused lessons. So we don't expect you to, learn or infuse all of these standards or concepts or all of this teaching strategies or all of the equitable teaching strategies. What we hope you do, what we're doing is we're offering you sort of a cafeteria style of, here are a lot of options, pick a few that you want to try out. All right, so when you see all these options, don't hopefully feel too overwhelmed. Experiment, this week really is a good week to try a lot of different things out, figure out what seems to work for you, where where your sort of sweet spot is, especially related to the grade you're teaching and the subjects you're teaching. And pick a few things out, and we're going to do that each week. We're going to give you like this menu of options and try some things out, and by the end of the week we hope you've kind of narrowed down so that by the end of this time you've kind of got it down. Anybody else want to add to that?
I'll just say there will be a few of you that are completionists and will try to do everything we talk about. You will fail. Your brain isn't big enough to learn it all in one single course. Pick a few and come back again next time and learn some more.
Yeah, and in fact, we're doing this in conjunction with the CS Institute. So the CS Institute is open to all educators. And so we have educators there who have come back to the CS Institute multiple times and ones that are new. So we always try to have a little, some new stuff for the people that have been before, as well as the stuff that we've done prior. So we actually always keep adding more and more and more. But that doesn't mean we expect you to do more and more and more.
I might say from a practitioner standpoint, as a teacher, just start thinking about lessons you do regularly or really enjoy, and maybe just talk about them this week and share with your colleagues and us, and we can start to brainstorm ideas and how this works. And I think it will seem more natural than it appears. So just start thinking about some of the stuff you really like doing with kids or you find natural engagement, and then these pieces will probably fall into place.
Eric, I'm so glad you mentioned that. You know, one of my jobs when I was at STAB was to be that person that a teacher came to and said, hey, I've got this lesson, I'd like to infuse CS, or you know, this is something I'd really like to try, but I've never tried before. That's why we're here. So if you start having those thoughts and ideas, please reach out to us. We are happy to help you brainstorm some things. All right, so like I said, we're going to start with the Virginia Computer Science Standards of Learning. They fit into these threads: algorithms and programming, computer systems, cybersecurity, data analysis, impacts of computing, networks, and the internet. It's a lot. And as I go, it's going to seem a lot more. One thing I want to note that I learned at a conference recently is a lot of these standards were written to be for a standalone class, that you could just go boom, boom, boom through these standards, and it was just about computer science. So the lens we want to take again is that we're integrating these standards into a subject or a lesson that you're already doing. And so it's not about checking off, again, the list of, I'm going to get all these standards. In fact, we're not even going to go through all the standards, but I was just surprised that, at least in this conference session I attended, at whatever state they were doing the standards, it might not have been Virginia, but they made a conscious decision to, even in K-8, gear the standards toward a standalone class, although those aren't available. So go figure. So actually, Luther, I'm going to think you have you go through this.
All right, so there's that big list. We're just briefly going to run through what you already do that is related and what we're going to help you add. So the first area is algorithms and programming. The core of algorithms and programming is the idea of an ordered set of steps. Simple things like how you move around the classroom and when lunch happens and so forth already is an algorithm. There's an algorithm to getting through the school day that you probably teach them in kindergarten, right? And as you get farther on, we teach them the algorithm of long division, this process of moving numbers around over and over and over again, which eventually gets the result and so forth. So you already do that, great. We're going to help you add a little programming component to it. Take some of those ordered sets of steps and teach the computer how to do them for you instead of just having the students do them. The next area we have is computer systems. So you already talk about how to use computers. You teach what the rules are, wherever the computers are in your class. There may be a great deal of variety from person to person here. The main thing we're going to try to add here is some other computer platforms. In particular, we're going to talk some about how to use robots and some of our hands-on activities. You'll get a chance to try out robot programming things that the students can do. There are also side materials you can consume about how to program phones and so forth. So we're going to try to help expand that set and talk more about how it works. The next area is cybersecurity. We're not going to cover it at all. There's already too much. We're just going to skip it. You're welcome to go on and on your own. Data and analysis, however, we are going to talk about. You already use numbers and digits to describe information. This is a fair amount of what we teach is how we represent information. We're going to add some more complicated representations. So how we can put these pieces together to make more advanced concepts. And then the last two topics, we're also not going to cover. The impacts of computing and networking and the internet. Again, there's some side information you're welcome to consume on your own, but it's not going to be the scope of what we're planning to cover in this course.
Thank you. So what I have been doing is taking each of these concepts and seeing if I can find some tutorials or, easy descriptions or things like that. So I'll be updating the slide deck as I add more things, but here is a way that you could do a deeper dive into any of these concepts that you're interested in learning more about. Sorry, I went too fast. So I have them for all three. So the ones I found are probably the ones, we're going to be spending more time on anyway.
And as Jenny noted in the chat, just because we're going to talk about three doesn't mean we don't know things about the others. If there's one of the others that you really want to talk about, come to our office hours, talk to us. We can definitely help.
Yes. All right. So just at the end here. So like I said, we're doing this for you all at CCS, but we're also doing a more broad course. They have the same thing. So this is the website for the broad course. The Canvas site that you have has the similar links. So we will be adding the kickoff video here. Hopefully you've already done the pre-survey, but if you haven't done the pre-survey, please do that before you start diving into this work. You'll do the pre-survey on the Canvas site, not the one here, if you're CCS. We have these videos as promised from Luther to take a deeper dive into CS and the experimentation culture. We've created this handbook, so we've been sharing these things across different CS institutes. So now we're trying to bring this together in one handbook. It is a work in progress, so things will be added to it as we go. But the CS education section is the part to read. We have the links to the slide deck, the SOLs. There is a cross-curricular integration alignment that the Virginia Department of Education put out, so that might be a good resource to start with. We're also going to have a Padlet here to, if you've got a resource that you love, please add it, because we'd like to learn from you and learn what else is out there. These are all optional. You do not have to do this, but if you wanted to take a deeper dive into anything, here's some recommendations. And then here's our do. So we are suggesting you pick 1 or 2 CS Unplugged activities to try. The first 2 are like specific ones, and then these are lists of activities if you want to see more options. What I would recommend, try one. If it was not going where you want it to, it doesn't seem like it fit, let that go and try another one. And then we also,
to be clear,
oh, sorry, go
sorry,
ahead.
I was just to be clear, this is trying one as a student. So
Yes.
like actually doing the CS activity. So take off your teacher hat and put on your student hat and actually like make the binary bookmark.
Yes.
So to be clear.
Thank you. Thank you. Yes, you're a student this week. So all this is through a student, all the do activities are through a student lens. So then we also want you to do 1 or 2 CS lessons. And we tried to break them up into grade levels. The first ones are some specific activities. And then there's also like Boot Up has a whole list of activities that you can do. So we tried to provide different ways to access these activities. Again, if you have one that you've done or you have a resource that you found, we'd love to find that as well. We have our office hours. So again, please do contact us if you'd like to meet with us over the weeks. And in the CCS Canvas site, there's discussion boards. And Jenny, are they split into groups?
No, but they will be shortly.
Okay.
Yeah.
So we're going to split you into smaller
everybody.
groups by grade level, right? And so we will be looking at those discussion posts, giving you feedback. We also hope you'll give each other feedback. And then there's also a reflection journal that you'll be keeping. All of this is part of the research practice partnership. And so we do use this data to do some research about how the professional development is going and what is working and what we can improve in the future.